All right, physical science students, we are getting started with graphing and interpreting data, and this is going to be just the notes you need to have. All right, so graphs in science are extremely important, so if you're using your guided notes, please follow along. So graphs are often used for information, to show the results of an experiment. They're found in like the data section of your report, and we're going to focus on these four main ones. There are different kinds of graphs depending on the type of information that you're using. So depending on what data you're trying to express depends on, or kind of dictates what kind of graph you're going to use or chart. All right, so when we want to show comparisons, we're going to use a bar graph. So what kind of pet do you own? Okay, 4 people have a rabbit, 8 people have dog, 10 people have cat, goldfish, hamster. So these are very like this many people have this, this is this, this is this. Take a look at the graph to the right. So what are they showing? Comparison? How do you know? Being able to read a graph is something that we're going to practice throughout the year, especially when we're looking at our physics portion, which is any type of Newton's laws. So energy, work, force, all of that can be depicted through graphs. So being able to read them is imperative, which means really important. So how many more red are there than purple? Well, we can look at the number. We got to look at the scale. So it goes by twos. So if one's in the middle, 15, there's 8 purple. So there are 7 more reds than there are purple. And frequency means like, are there 2 bars that are the same height? Line graph is going to show you some change over time. We're going to hit these heavy and hard when we get into velocity and acceleration and speed. So you're going to see these guys come back. So as the year goes on, emissions go up, that type of thing. So that is showing a correlation. This is what you would see like in math class when you're doing slope and points on a graph. This is kind of the same. This isn't kind of. This is the same idea. And I can show you the mathematical reasoning behind it as we get more into them. All right, here's another line graph. We have our time. So what change over time in the graph is representing. So that's going to be on the x-axis. The y-axis is going to be over here. This is my independent variable. This is my dependent variable. So make sure that you are becoming comfortable with those terms. Pie chart or circle graph, I always call it a pie chart, shows comparisons of a whole. So out of 100%, this is what it is. What does the pie chart represent? It represents your favorite pizza toppings. What's the most popular choice? It's going to be the one with the biggest amount or the highest percent. That's pepperoni. What's the least popular choice? Supreme. That's not a pizza topping. Well, anyway, that's going to be your smallest slice of the pie equals your smallest representation. We have tables. So tables are very good at reporting data and showing you everything kind of, here's all the numbers behind everything. These are going to come up in standardized tests. Being able to decode these is a really good skill to have, because then you can tell if information is being presented well or if it's kind of a little sketchy. All right. So we have our densities. So with the metal and then the density. So according to the table, which one's more dense? That's going to be the one with the highest density. So all you have to do is to kind of just peer around and see. All right, gold has the highest density. So if water has a density of 1 grams for every cubic centimeter, which metal would sink? So that's basically saying, all right, anything over 1 is going to sink. And that is all of them. And the table represents densities of some common metals. So always label your graph with a title. In fact, here's what you should do. It's a kind of a silly acronym, but SALTAN is something you can use. We need to make sure that our scale is consistent. So I'll go back. So you see how this is done in 1, 2, 3, 4, how that's done. And then this is done in 2, 4, 6, 8. There's not a jump. So if you're going to pick whatever scale you're going to pick, it doesn't have to be by ones, it doesn't have to be by twos, but it has to be consistent. So if you're going to count by fives, it's got to go fives all the way up. If you're going to count by tens, it's got to go all the way up. So this one's done in 50s, so 0, 50, 100, 150. Need to keep that consistent. If you ever see a chart like that out in the real world where their numbers aren't in kind of that scale, then it's not something to trust. So we have our units. Always make sure your units are labeled. I need to know what the numbers are. What do they represent at all times? We got to label our X's and our Y's. So remember, your X is your horizontal, your Y is your vertical. There has to be a title. We want to try to be as accurate as possible. When we're doing handwritten graphs or handwritten charts, sometimes things aren't as perfect as they could be, especially if you don't have graph paper, but you want to keep it as best as you can. And then, of course, you want it to look neat and have it be legible, which means I can read it, you can read it, partner can understand it. If I show it to another teacher, they can understand it. That's the last slide. Yep. So we are not going to go over this video, but I will see you guys in class, and we are going to practice more graphs.